Have you ever wondered why SQL Server finds some data almost instantly, but other queries take much longer? The answer is usually indexes. But there are two main types of index, clustered and non-clustered. By the end of this video, you will know exactly when to use each one. Hi everyone, I am Riaz. Welcome to Code with Riaz. What is an index? Before talking about different types of indexes, let's first understand why indexes exist. Imagine the order table contain 10 rows. Today it doesn't matter much, but imagine this table has 10 million rows. If I search one customer for like a customer like John Smith, the process the SQL server had to check row after row until finds John. That process is called table scan. It becomes slower as the table grows. Indexes solve the problems. Let's look into a real example. Uh, I don't have any tables here, so let's create a. Okay, I have an order table. Let me check, but I don't have any record in this one. So let's create some data. So I have already created some value here. Okay, let's do a small example because this order table, if I go and check the design, it doesn't have either primary key or there is no clustered index. So there is no primary key and there are no indexes. I say keys, all are empty. So let me change something like I'll make this as 10 and I make this one as 9. We'll see how it stores. Run this one. Now 10 records has been inserted. Now let's execute this query. Now if you see the order, it's if you see the order, it say like 1 to 8 and then 10 and then 9. So this is very good example for us. Let's begin. So let's create a cluster index. So before we start with cluster index, let's give a small example. Think of a dictionary. The word inside the dictionary are already arranged alphabetically. You don't need another list to find a word. The data itself is already sorted. This is exactly how a clustered index works. The table data is physically stored according to the clustered index key. So let's create a index, cluster index. One second. Where's my So let's me copy this one. So create cluster index, some index name on orders table. So I'm creating on orders ID. So let me execute this one. So now it has created a clustered index. Sorry. The moment it creates a cluster index, the data will be automatically arranged, as I said in the example of dictionary. So if I run this one, if you see here, the order table, the data is arranged now. Now you can see the SQL Server stores the rows in the order of order ID. If new rows are inserted, SQL Server keeps this order. For example, if you create order number 1020 and then create another record with order number 1015, So 1015 will come first and then 10220. It will display in that order. And cluster index, we can do index only for one column. There can be only one clustered index. You may be thinking why there will be only one. Why can't we have more than one? Because data can be stored in one physical order. So here, if in this example, the data is stored in ordered ID. So let's take another example. Imagine arranging book on a shelf. You can arrange them alphabetically or by publication date or by author. But you can't arrange the same books in three different physical orders at the same time. That's why every table can have only one clustered index. If you want to have more than one index, we can use non-clustered index. So let's move to our non-clustered index example. So here, let's comment this one. So non-clustered index doesn't rearrange the whole table again. Instead, it creates, when we create a clustered index, it creates a separate structure. SQL Server creates a separate structure. It's store, for example, we do have we do have customer name. So we can create a let's create an clustered in a non-clustered index for customer name. Let me So the syntax is almost same. Instead of clustered index, we put here create non-clustered index and the index name on which table and which column. So let me create this one. Now what happens is the SQL Server creates a separate structure. It stores customer name and a pointer that tells SQL Server what the actual row is where the actual row is located. It doesn't move the data. It simply creates a faster way to find it. Let's take a small example. Okay. Think of the index at the back of a textbook. It doesn't contain the whole chapter. It simply tells you the chapter, the page number, go there. That's exactly what a non-clustered index does. When can we use when to use clustered index? Like choose columns that are unique, stable, frequently used for sorting. Usually we use it for primary keys. So in this example, we can use it for order ID. And for non-clustered index, choose column that users search frequently. For example, we can search by customer name, we can search by email address, we can search by order date, we can search by order status. So we can create more than one non-clustered index. Many developers thinks more indexes means better performance. That's false. Indexes also need maintenance. Every insert, update, delete must update the indexes too. Too many indexes can actually slow your application. Remember a few points. Cluster index, only one per table, stores data in sorted order. Non-clustered index, multiple allowed, store pointers to the data. Indexes improves read performance. Too many indexes reduce write performance. I hope you understand the clustered and non-indexes much clearer now. Remember, good SQL isn't about the right result. It's about the getting the right result efficiently. I'll see you in the next video.